Good day, everybody. How are you all doing? Today we are going to talk about measures of spread. So I'll share my computer screen with you. So measures of spread. So these are the objectives. Suppose you are deciding between living in San Francisco and St. Louis. One thing you might consider is weather. The table presents the average monthly temperature in degrees Fahrenheit for both cities. And we have 12 months, so 12 data points. These are 12 months in a year, so this is a population. So we can calculate the population mean for temperature for both the cities. The mean temperatures for both cities are similar, 57.5 degree for San Francisco and 56.1 for degree for St. Louis. However, temperature in St. Louis are more spread out than those in San Francisco. At the bottom, they have done the dot plot for temperature. As you can see on the top horizontal line, it's a number line from 30 degree Fahrenheit to about 80 degree Fahrenheit. Most of the temperatures on the top line, which is the temperature, shows the temperature for San Francisco. The points are closely clustered around the center value of 57.5. But if you look at the bottom line, which shows the dot plot for temperature of St. Louis, there is quite a bit of spread, with the minimum being 30 and a maximum of around 79. Okay, so quite a bit of variation in St. Louis as shown by the number line, the bottom number line. The mean only gives a measure of center, but to describe a data set, we also need to measure the amount of spread. That is how much, on the average, the individual temperatures vary from the center. That will what we are trying to measure. So compute the range of a data set. The range is the simple way to measure spread. The range of a data set is the difference between the largest value and the smallest value. For San Francisco, it is 63 maximum in September, minus 51 in January is 12. For St. Louis, the range is 79 in July, minus 30 in January, which is 49. Although the range is easy to compute, it is not often used in practice because it only involves two values from the data set. So to calculate the range, we just need the maximum temperature and the minimum temperature. Maximum minus minimum is the range. So as you can see, the range only takes into account two values in the entire data set. So it is not a good measure of the spread of the data set. As I said, our goal will be to find out on the average how far each number is located away from the mean of that data set. So we are going to calculate first the variance of a population and sample. Variance is a measure of the spread. When a data set has small amount of spread like the San Francisco temperatures, most of the values will be clustered around the mean or close to the mean. When a data set has a large amount of spread, more of the data values will be far away from the mean. The variance is a measure of how far the values in a data set are from the mean on the average. How far the numbers are located away from the mean of the data set on the average. The variance is computed slightly differently for populations and samples. The population variance is presented first. Let x1, x2, x3 up to xn, where n can be any value, denote the values of a population of size capital N. Let mu denote the population mean. So the variance, population variance is a square quantity, sigma square. As I told you before, all population characteristics are in Greek symbol. So this is Greek S square or Greek small s square or Greek sigma square is equal to, and as we discussed before, when we were talking about mean, this particular slanted M is actually capital S in Greek language called sigma, which is sum. So we, on the numerator, we have xi minus mu square. That means for each number, xi, From that, we are subtracting the mean. How far each number is located away from the population mean. That is the difference. And then we are squaring it. And the summation sign means we take the square of the deviation of each of the numbers in the data set from the mean, adding them together, the square of the deviations, that and adding them together is given by the symbol sigma. So the sum of the squares of the deviation is divided by population size, gives you variance. So variance is a measure of the square of average deviations of the numbers from the mean. So it's a square, though, it's a square unit because each number difference we take from the mean and square it. The reason we square it, some of the numbers will be smaller than the mean, hence the difference will be negative. But if we square a negative number, suppose the difference is -2, xi minus mu is -2. But if we square it, that is -2 times -2. Two minuses make it positive, 4. So square of a negative quantity is positive. That's why we square the difference of the number from the mean. Do it for all the numbers, add the squares and divide by the population size to get an average of the squares of the deviations of the numbers from the mean. Compute the population variance for San Francisco temperatures. So first we find the mean and do it. So we are not going to do it this way. We are going to do the calculation using the calculator. So what will I do? Put my TI-84 calculator on, then press the second button. Okay. Then the plus button, then number 4. So second button, plus button on the bottom right on top of the enter button, then number 4, clear all list and hit enter. Done. We cleared the memories of the calculator. Now we will enter the San Francisco temperature for the 12 months in L1 of the calculator, list 1. So we press the start button, then number 1, then we enter the temperatures in L1, 51, 54, then 55, then 56, then 58, then 60, then 60, then 61, then 63, then 62, then 58, and then 52. So we have 12 data points, 12 temperatures for the 12 months of the year for San Francisco in L1. Now we need to calculate the population mean, population standard deviation, all this uh, um, properties of the population. So how do we do that? We press the stat button again. Then, much like before, we highlight, means we move the cursor on the top row from edit to calc. And then we use number 1, which is one where stat. So stat, then calc, then edit, then number 1, one where stats. Press number 1, one where stats. List is L1. Frequency list, the second line. After the colon should be empty. If there is something, press the clear button and then go down to calculate and hit enter. The population mean, although it is given as X bar, which is sample mean, the calculator does not know whether it's a population or a sample. In this case, X bar, and the formula for calculating the population mean and the sample mean are the same. So therefore, in this case, because there are only 12 months in a year, it's a population mean is 57.5. How about the population variance? We do not get variance straight away in the calculator. However, we get sigma x, which is population standard deviation, which is the square root of the variance. So we have to square or multiply by itself the standard deviation, population standard deviation, that is Greek symbol, because there are two standard deviation in the calculator. One is for the sample, Sx, and one is for the population, sigma x. The one we are interested in this particular problem is sigma x because this is population data. So this is 3.7528. So let's type in a calculator separately 3.7528. It was 277. I rounded it to 28. 3.7528 for the standard deviation. I have typed separately in the calculator. Now I'm going to square it. Why am I going to square it? Because that will give me the variance. The square of the standard deviation is variance. So I'll press the X square button, which is in the first left column of the calculator, and hit enter. So when I press the X square button, I get the exponent 2, I square it. The variance is 14.083, same as what you have in this calculation. Of course, we will use the calculator. We are not going to use this long formula. So that was sample variance. If you notice, I mean, population variance, the formula for population variance is given here. It is divided by the population size. So it's a variance is an average of the squares of the deviation, right? But for the sample variance, same idea, average of the squares of the deviation from the mean, individual number from the mean. However, in the denominator, it is divided by n minus 1. A lot of people think, why don't we divide by small n, just like we divided by capital N for the population? The reason we do not divide it just by n, because we use the sample data to calculate x bar. Therefore, we used the information once. So statisticians think of, therefore, since we have used the information once to calculate X bar, statistician thinks of it as losing 1 degree of freedom. And therefore, when we use it, same information to calculate the variance, we will divide it by n minus 1 because we lost 1 degree of freedom. For our case, we will get Sx from the calculator, okay, and then square it to get the sample variance. Okay, so I'll skip this. I explained to you. Okay, find the sample variance. This is a new type of battery is being tested for laptop computers. The lifetimes in hours of 6 batteries are given. Find the sample variance. So let's enter the data in the calculator. So the first thing is second, then the plus button on top of enter button on the bottom right of the calculator. Then number 4, we get clear all list on the calculator, hit enter. Then stat 1. In L1, there's 6 batteries, 3, 4, 6, 5, 4, and 2. Okay, so we have entered the lifetime in hours of 6 batteries in L1. Then we press the stat button, highlight calc on the top row by moving the cursor to calc and highlighting it. Then we select number 1. List is L1. We don't do anything. We go down straight, bring the cursor down on calculate and hit enter. The Sx value is, that is the sample standard deviation. Remember, we in our calculator, we get the sample standard deviation and then we got to square it to get the variance. So let's take 1.4142 as the sample standard deviation. Notice where I am using the value for Sx in the calculator. So in the calculator, I type separately 1, the standard deviation value 1.4142. To calculate the variance, I have to square it. So I press the X square key, which is in the first column, left, extreme left, halfway down, square it, and then hit enter. And the variance is actually 1.99999. So we can easily round it to 2. Same answer as these guys have gotten using the formula. So the variance is 2. The square root of 2 is 1.4142, which is the standard deviation. Okay, so you get the idea. Okay, let's do this. These are credit card debt. Okay, the credit card company is studying the levels of credit card debt held by college students. They select 8 students at random. Sample. The balances are, find the sample variance of the balances. So what will we do? Second button, then plus, and then 4, clear all list, hit enter, done. Then stat 1, in L1 enter these numbers, 342, 541, 1652, 43, 87, 137. Remember, we have to enter 02 and 418. Okay, so these are numbers, sample of 8. Okay, so we need to calculate the sample variance of the balances, which is a square of standard deviation. So stat calc 1, list is L1, calculate. So we get Sx as 540.58. So we type 540.58 and then x square it and hit enter. And the variance is 292,226.74, close to 292,230. Compute the standard deviation. So in the formula, we calculate the variance, then we take the square root to get the standard deviation, both for the sample and the population. However, in our calculator, we will get straight Sx and sigma x. We have to decide which value should I use, sigma x or Sx. That depends on the problem. For San Francisco temperature, 12 months in the year, I have 12 data points. It's a population. So in that case, I will use sigma x. Battery life, 8 batteries, sample. So in that case, I would have used Sx. Okay, so this is how the calculate showed you how to do it using a calculator. Recall that statistic is resistant if its value is not affected by much by extreme values, large or small in the data set. The standard deviation is not resistant. That is, the standard deviation is, notice the underline under is affected. What does it mean? If you have too many high values and too many low values in a data set, both will affect the standard deviation, the value of the standard deviation. Find the sample variance. Again, you enter this in L1, then calculate Sx, and then you square it to get the variance. So let's enter it. Second, then plus button on top of enter button, then number 4, clear all list, done. Then stat 1, enter the numbers in L1, 2, 2, 1, 5, 4, 5, 0, and 1. Now stat, calc, okay, remember there's sample. So number 1, list is L1, second line is empty, calculate. So I'm interested in Sx. Sx is 1.927. So that's your standard deviation. I'm taking the sample standard deviation value because this is a sample. So even if you use 1.927, it might be you can use 3. That's your standard deviation. We squared that to get the variance, x square button. So in the calculator, you first get the standard deviation, then you square that number to get variance. So variance is 3.714. Yep. And then similar way, in the second problem, you will use sigma x instead of Sx because it's a population. Okay. Approximate the standard deviation with group data, same idea. So basically, we will enter the midpoints in L1 and the corresponding frequencies in L2. Okay. So let's enter the midpoint. So the first midpoints in L1. So these are the midpoint. So the second column is the midpoint. So second plus 4. Clear all list, done. Then stat button, then 1. So the midpoints go in L1, which are 25, 75, 125, 175, 225, and 275. Okay. Now the corresponding frequencies will get into L2. So I press the right cursor key, which is in the top right corner of the calculator, so that the cursor moves to the first line in L2. And there I will enter the frequencies. Here the frequencies are in the second column. So 10, 5, 13, 11, 7, and 4. Okay. So midpoints in L1, frequencies and in L2. Then stat, highlight calc on the top row. Then number 1, 1 where stats, list is L1. Now frequency list, I've entered the frequencies in L2. I have to tell after the colon in the second line to put L2. How do I do that? I put the cursor after the colon in the second line, then press second button and 2. That puts L2 there, and I calculate. Okay. So the standard deviation, okay, is Sx, because it's a sample, is 77.3014. So how do I get the variance? I type in the calculator 77.3014, and then I square it, and the variance comes out as 5975.506, very close to what they have gotten by the formula. Okay, and they show you how to do it with the calculator. So empirical rule to summarize data are unimodal and approximately. So if a data is bell-shaped, that's a unimodal. There is only one point on the horizontal axis which has the highest peak, highest frequency. And it's bell-shaped means left half is equal to right half, then it's approximately symmetric. Okay, so this is a bell-shaped. Look at the center, look for the class with the highest frequency or highest height of the histogram. That's the highest frequency. Look to the left of it, look to the right of it. They're approximately equal, so they're approximately symmetric or bell-shaped. So this is the empirical rule. What does empirical means? Observed rule. What does it say? Remember, at the center is where the peak is the highest. That is where the mean is. From the mean, if you go one standard deviation on the right and one standard deviation on the left and draw two vertical lines, within those two vertical lines, 68% of the data will fall. Again, from the mean, if you go two standard deviation on the right, draw a vertical line to hit the curve, and again go two standard deviation on the left on the base, on the horizontal axis, draw a vertical line. The area between these two vertical lines at two standard deviation on the right and two standard deviation on the left is 95%. And if you go three standard deviation, almost all, actually technically it's 99.7% of the data will fall within three standard deviation of the mean. This is empirical rule because this has been observed again and again, and this only applies if your distribution is approximately bell-shaped or approximately symmetric, means the left half is equal to the right half in terms of the bell. Okay. So here it is shown in the picture. If you go one standard deviation on the right, one standard deviation on the left, and draw two vertical lines. So between those two vertical lines, the area under the curve, bell-shaped curve, is 68%. And if you go two standard deviation on the right and on the left, draw two vertical lines under, between those two vertical lines at two standard deviation, area under the normal curve is 95%, and three standard deviation is almost all. So basically they're showing what is the mean and standard deviation of these numbers. Then they calculate mu plus sigma and mu minus sigma. They look at the points, look at the rectangle on the top left, mu minus sigma value and mu plus sigma value are given. You draw two vertical lines. Area under the curve should be approximately 68%. That means 68% of the data will fall between 11.57 and 14.93, as shown on the right. And that is indeed true. Okay. Here is a large class of 200 students took an exam. The score at sample mean X bar 65, sample standard deviation 10. Histogram is approximately bell-shaped. Approximately how many students? So between 45 and 85. Notice 65 minus 20 is 45, and 65 is the mean plus 20 is 85. That means 45 and 85 are located two standard deviation away from the mean, one on the left, one on the right. And empirical rule, approximately 95% of the data will fall. So 95% of 200 is 195. 0.95 times 200. The 0.95 comes because the points 45 and 85 are located two standard deviation. 45 is below the mean, 85 two standard deviation above the mean. and then we use the empirical rule. Decide in each case whether it will be appropriate to use empirical rule. The one on the top left, blue, maybe, approximately bell-shaped. One on the top right, no, it's skewed to the right. One on the bottom left, no, because it's skewed to the left, negatively skewed. One on the bottom right, yes, approximately symmetric, and you can use the empirical rule. So next is Chebyshev. Notice empirical rule can be applied only in case of the frequency histogram bell-shaped, approximately symmetric. How do you get the bell shape? You join the top roofs of those vertical rectangles and you get a bell shape. But sometimes distributions are not bell-shaped. Then what do? Then we use Chebyshev's inequality. When a distribution is bell-shaped, we use empirical rule to approximate the proportion of data within one or two standard deviation of the mean. Another rule called Chebyshev's inequality holds for any. So if the distribution is not bell-shaped, then we resort to Chebyshev's inequality. Chebyshev says at least 1 minus 1 over k square of the data will fall within k standard deviation of the mean. What do they mean? If k is equal to 2, okay, k is equal to 2, then what happens? At least 3/4 or 75%. How do you get 3/4? Because 1 minus 1 over 2 square is 1 minus 1/4, or 4 over 4 minus 1 over 4 is 3 over 4. So at least 75% of the data within two standard deviation of the mean. This applies if the probability distribution histogram is not bell-shaped. And if you go 3 standard deviation, it is at least 8 by 9 or 89%. And this will again apply to any kind of distribution. Okay. As part of a public health study, systolic blood pressure was measured for a large group of people. The mean was 120, standard deviation was 10. What information does Chebyshev? So we do the calculation for 2 standard deviation and 3 standard deviation. 2 standard deviation is 2 times 10, 20. So 120 minus 20 is 100, and 120 plus 20 is 140. So between 100 and 140, at least 75% of the data will fall. And you can repeat the calculation for 3 standard deviation, at least 89%. Okay. Both Chebyshev's inequality and the empirical rule provide information about the proportion of a data set within a given range number of standard deviation of the mean. An advantage of Chebyshev's inequality is that it applies to any data set, whereas empirical rule applies only to data sets that are approximately bell-shaped. A disadvantage of Chebyshev's inequality is that for most data sets, it provides only a very rough approximation. That is why they say at least. They do not say, like in empirical rule, they say approximately 95%. They nail it down for 2 standard deviation. Whereas for Chebyshev, for 2 standard deviation, at least 75. So 75% is the minimum. It can go any high. For empirical rule, it is approximately 95% for 2 standard deviation. And what is coefficient of variation? It is standard deviation divided by mean. Basically, if the standard deviation of a distribution is large, then the CV will be a large number. Basically, CV shows us what fraction or what proportion of the population mean is the standard deviation. Okay. So here is the situation. For one particular place, Atlanta, mean rainfall, okay, annual precipitation, and the annual temperature. So calculate CV for precipitation. It is standard deviation in temperature divided by mean. CV for precipitation is standard deviation for precipitation divided by mean precipitation. It is 0.15. What does it mean? It means the standard deviation in precipitation is 15% of the mean, quite a bit of variation. Now look at the CV for temperature. It is 0.02. That means standard deviation for temperature is only 2% of the temperature, mean temperature. Less variation in temperature than in precipitation. So length of newborn babies have a mean of 20.1 inches, standard deviation is 1.9. Find the CV. So CV will be 1.9 divided by 20.1, which is 0.0945. Or it means the standard deviation is 9.45% of the mean. Okay. That's it for this section. I'll stop here today. If you have any question, write me a comment. Please write me a comment. Want to know what's your feeling after reviewing this video. And if you like this video, please give me a thumbs up. If you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. And please do not forget to watch me tomorrow when I come back with another new video. So my channel, please subscribe and let YouTube know that you'd like to be notified every time I upload a new video, which I do almost every day. Just hit the click button and click the bell button, okay? And please subscribe. Thanks for watching. Take care. Have a nice day. See you next time.